Good morning. Ohayo gozaimasu. Thank you for coming to the mQACC workshop. Today we're going to start talking about our living guidance, and let me start sharing the slides. There you go. Okay, so thank you for coming to our workshop. The title of our workshop is Unveiling the mQACC Living Guidance for QA/QC Best Practices in LC-MS-based Untargeted Metabolomics. And if you haven't visited our website, this is the QR code you can scan and see more information about the mQACC Consortium. We also have our email and X that you can follow. So the next 120 minutes, we will talk about disseminate key practices identified through 5 years of community engagement and consortium effort to launch preview of living guidance document and accompanying website. These are the presenters that you will hear from. I am Ping-Ching Hsu from University of Arkansas for Medical Sciences in the United States. And Calum from UK will talk about living guidance document and website. Raquel from Spain will talk about pool and intra-study QC samples, minimum and best practices. Dajana from Canada will talk about use of internal standards, minimum and best practices. James from Canada will talk about design of the analytical batch, minimum and best practices. And Diana from Canada will guide everyone with the short guided discussion after each topic. And because our polling question, we'll need to use the conference app. So I want to check with everyone. Is there anyone that have not downloaded the app for the conference? Okay, oh, there's one. So if you haven't already, please download the conference app, and we will use that for our polling questions in the next. So what is quality control and quality assurance? So quality control is processes related to the procedures applied during and after data acquisition. And quality assurance is processes related to the procedures applied in preparation for data acquisition. And these work were, if you want to know more detail, please look at our published work in 2020. And so the mQACC Consortium is, I'm going to talk a little bit about the history of mQACC and early developments. So mQACC was formed following a think tank meeting at the National Cancer Institute in the United States in October 2017. So the mission is to engage the metabolomics community to communicate and promote the development, dissemination, and harmonization of best QA/QC practices in untargeted metabolomics. Since the inception in 2017, the think tank has developed into an international consortium, and we published our first paper in 2019 in metabolomics. And since then, we now have more than 120 members, including scientists from 5 continents, from academia, industry, and government organizations. So this is our mQACC structure. We currently have 3 coordinating committees, including Jennifer Kerwin, Jonathan Mosley, Annie Evans. And I'm currently serving as secretary with Leo. And we have 3 working groups, including reference and test materials, led by Clay and Raquel. We have a task group. We have a working group, community engagement, led by Claire, Haley, Brianna, and Goncalo. And we have our working group, best practice working group, led by Diana and Georgios. And under the best practices group, we also have 4 different task groups, including MMR task group, GCMS task group, reporting standards, quality assurance task groups. So the whole consortium often centering our discussion about what is best practice, what is common practice, what do we need to report, how can we improve practices, and how do we adapt to new technologies. So the objectives of the workshop today is to disseminate key practices identified through 5 years of community engagement across 3 relevant technical areas, focusing on untargeted OCMS metabolomics. We also have forum for critical discussions to further fine-tune both format and content of the mQACC living guidance and encourage wide community adaptation of best current practices. So these are the working group. This is the group effort from that they work out for this living guidance. So thank you for your attention. I'll welcome the next speaker, Callum.
Okay, hello everyone, good morning. Ohayo gozaimasu. My name is Callum Martin. I'm a software developer on the metabolites team at the EBI in Cambridge, England. But I'm also a member of mQACC, and I'll be briefly talking about the Living Guidance document and what it is and how it works. Okay. So the Living Guidance document is intended to support the Untargeted Metabolomics community in all aspects of QA and QC. And by living document, we mean that we intend to add to it and revise it periodically, both in response to workshops like this, but also individual bits of community feedback, issues people raise, people think corrections need making, or that a piece of guidance is outdated. We want to be able to capture all of that, and we'll be able to have the document itself evolve over the course of its life. So it includes minimum practices, things we think you absolutely should be doing in your untargeted experiments, optional best practices, examples of use cases and case studies that you can refer to help you design your QA and QC as part of your experiments, and it is intended to be non-prescriptive. So it's as a reference, it's not supposed to tell you exactly how to do everything. And we want it to be very clear that you can contact mQACC with input regarding the guidelines, and we want to make it clear how you can get in touch with us. So these are the key areas that are covered by the Living Guidance document. Broadly, they are pooled QC, system suitability testing, internal standards, analytical batch design, metabolite annotation identification, reference materials, data quality, and quality assurance. So these are all areas that we've been gathering information as part of polling, talking to the community themselves, having internal discussions about the best way to come up with the guidelines for each of the individual topics. Okay, so there are some considerations from a technical standpoint in terms of how it would actually work. So the people writing the Living Guidance document itself and who will be managing it aren't themselves web development technical. So any app that we wrote from scratch, that we coded from scratch, if that would imply development maintenance overhead, and that would need a developer to look after it, which mQACC is a voluntary consortium, there's no dedicated resource. So we need to be realistic about how much time is going to be able to be spent looking after the Living Guidance document. So to be practical long-term as well, it needs to be friendly to non-technical users. Someone needs to be able to be instructed how to manage the Living Guidance document, how to update it, how to publish it, and ideally that would involve little to no code and no interaction with the command line. And so being able to do all of that from a single place, from a dashboard, be able to manage updates, be able to consult previous versions, be able to publish it, be able to get DOIs, being able to do all of that from a single place would be ideal for someone who has to manage it but isn't necessarily technical. And so it's important for previous versions to remain accessible and uniquely citable. So the document might look very different in 5 years' time, and someone who was citing it tomorrow, if it was available, might want to make clear that they were citing the version of the guidance that was available at the time, not the guidance as how it looks in 5 years' time when there might be a bunch of corrections. So we need unique DOIs for each version just to make clear what people are referencing when they do cite the living guidance document. So this is just a brief outline of how the change and release pipeline might work. The general plan is to update the guidance annually in response to community feedback, individual issues, and corrections that we ourselves realize need to be made. The intention is that it's going to be version controlled by design, so every previous version, every single change should be persisted, should be available, and should we need to, we can roll back changes, and you should be able to browse every single version of the document. Each new major version that we release, ideally annually, will have a new DOI for easy citing, and all suggestions and change requests, no matter who makes them, will be submitted to the mQACC committee. And if we decide to action them or we don't, we'll respond to say, oh, we've made this change, or sorry, we don't think that this change is appropriate. And once we decide we want to release a new major version, we can kick off an automated pipeline that will update the major version number, compile a PDF, get a new DOI from Zenodo, and update the website all with the push of a button rather than having someone to do that manually. Okay. So if you scan the QR code there on the screen, you can see a demo version of the living guidance document. It's only a very small subsection of the overall document, and the content isn't complete, will likely be subject to further change. It's mostly just intended to illustrate how it will look, the style of writing, how you'll browse it in terms of the document itself. It's hosted on a platform called Gitbook. It's going to stay up for the duration of this workshop only, and shortly afterwards we'll take it down because much of the content still needs finishing, and once the whole document's ready to publish, it will be up and ready. Okay, I'll give everyone just a couple of minutes just to browse the living guidance document. If that QR code or TinyURL doesn't work, please let me or one of the organizers know. We can come over and help, but I'll let everyone have a browse. Okay, I'm going to move on to the last bit of my presentation. Feel free to keep browsing the document. It'll be up for the duration of the workshop. If you have any feedback, please talk to me at some point during the workshop or to one of my colleagues. We'll be more than happy. We're looking for feedback as much as possible. So the last thing I've got to talk about is the infographics. So as part of previous workshops like this, we've had interactive forums that have driven both the living guidance document and the infographics that you can see on the screen here. So these infographics cover some of the same content as the living guidance document that you've just seen. It covers pooled QCs, internal standards, and the design of the LCMS analytical batch. If you go to that link or you scan that QR code, you can find high-resolution copies of those infographics ready for download. We intend for them to be printed out, disseminated to anyone working with untargeted metabolomic experiments. We want them to be printed off, hand to hand, for people to refer to, and they're supposed to be easy to digest, quick to refer to. And if you're interested in the polling results that have driven both these infographics and the living guidance document, you can find those polling results on the mQACC website as well in the output section. Okay, that's it for my portion of the presentation. I'm going to hand over to my colleague Raquel.
So now I'm going to introduce you the Living Guidance Glossary. Those are a set of definitions. So, what do we mean by pool or intra-study QC? It's a small aliquot of each biological test sample, which is pooled in a single QC. Then this QC is aliquot in identical approach and prepared as the biological test samples. What is an analytical batch? It's the collection of experimental samples and QC samples, including but not limited to blanks, experimental sample replicates, and other pertinent quality-related samples from a study that are processed at one time and analyzed in a single, non-stop instrumental run. It's a series of continuously analyzed samples. The types of blanks and definitions, we have 3 different blanks. We have the solvent blank, which is used for the detection of carryover, mostly run after high concentrated samples. It's used also for the detection of contaminants from extraction solvent and an LC system only. Then we have the process blanks, which are used for the detection of interferences or contamination introduced by any part of process, including the analytical system, columns, vials, or the sample preparation step, for example, from pipetting. And finally, we have the system blank, which is used for the detection of contaminants from the mobile phase, and it's for LC system only. The internal standards are exogenous compounds which are intentionally spiked into some or all the samples in a process and are used to help assess the data quality. On the other hand, the system suitability sample is a mixture of authentic chemical standards in a solvent blank. It has an assay-specific composition, comprises selected analytes with different physicochemical properties and molecular weight to cover different retention times and MZ values. And it's used to evaluate the instrumental setup before starting an analytical batch. So for the living guidance, what do we mean by minimum and best practices? The minimum practices are applicable to all studies and based on fundamental principles. All untargeted metabolomics studies would be expected to address these components regardless of the type of application. Those bear the minimum requirements to judge the quality of the study. The minimum practices are required. On the other hand, the best practices are those that may be the study and or the application dependent, so may not apply to all studies. These practices for the community to strive for, but are not necessarily currently adopted. These best practices are expected to change and evolve over time. The best practices are optional, suggested, or recommended. So now I will go into the use of the pool QCs in LCMS-based untargeted metabolomics. First of all, the creation of the pool QC samples. It's primarily generated from equal aliquots of all biological samples. It's a representative subset. It's also dependent on the time of creation and matrix dependent. The pool QC samples from biofluids or also other matrices used when we asked the community, we found that they were used directly from the sample pre-extraction step. and also for the other matrices from the sample extract during the extraction process or from the reconstituted extracted samples. The first ones are used to evaluate the extraction and instrument variance, and the last two for the instrument variance. The proposed minimum practice is to evaluate the technical repeatability of all features quantitatively using a representative sample which is injected throughout the study. When to inject the pool QC samples? When asked the community, the majority were injecting them between the 5th and the 10th biological sample, and the minimum practice is the same one. So for the pool QC, the best practices would be, first, to evaluate the instrument performance before, during, and at the end of the study as part of an inter-study or inter-study continuously quality program. This will include evaluate the chromatographic parameters, including peak width, shape, the asymmetry and or detailing factor, the area, and or the height using selected features. For example, from the pool QC or the system suitability samples. It will also evaluate the mass spectrometric parameters, including MZ, the isotopic ratio fidelity, and or the spectral fidelity, that's the ad hoc formation and in-source fragmentation, using selected features, again, for the pool QC or system suitability samples. It will be also to evaluate the technical repeatability of all features quantitatively, using a representative sample which is injected throughout the study. For example, for the pool QC samples. And it's a set predefined acceptance criteria for the instrument performance. The second best practice is the use of data from the quality control samples to accept or reject an analytical batch using predefined accepted criteria. The third best practice is the use of the dilution series of pool QCs samples to evaluate the relationship between signal intensity and concentration. If used for evaluation of the linearity, also pre-concentrate the pool QC samples. The fourth best practice is, where feasible, perform long-term monitoring of the quality control data using laboratory information systems, LIMS, and or logbooks. This can serve as a helpful failure forecasting tool. The fifth best practice is the phenotypic quality control samples are used to highlight differences in precision in case control samples and to evaluate the performance of low concentration analytes. And the last one would be the use of data from quality control samples to monitor and, if needed, improve the data quality. For example, the correction of within and between batch effects, to filter features by detection rate, repeatability, and or linearity. From the best practices, the minimum practices that are proposed are number 1 and 2 that I just have explained. To evaluate the pool QC, we can do a visual inspection via PCAE, including all biological samples and the pool QC samples. We can also perform a quantitative metric, the features detected in a percentage of the QC injections, and calculate the relative standard deviation. The minimum practice is to evaluate the technical repeatability of all features quantitatively using a representative sample which is injected through all the study. Also, minimum practice use the data from the QC samples to accept or reject an analytical batch using predefined accepted criteria. When asked the community regarding the use of dilution series of a pool QC for filtering features, the majority said no. However, it is a best practice to use a dilution series of pool QCs to evaluate the relationship between the signal intensity and concentration. As a summary, the pool QCs serve multiple purposes within a metabolomics workflow. The creation of pool QC is matrix, practical, and purpose-dependent. The injection method, frequency, and placement are specific to instrument and method. And finally, move forward to quantitative metrics for data evaluation and reporting. Now we will have a couple of polling questions. Here I show you the instructions to participate. You have to go to the Attendee app on your mobile device, select the agenda icon, click our session, which is workshop number 8, and select poll. Okay, if anyone cannot find it, please tell us and we will assist you. Okay. Dajana, I start with the questions? Or? Yep. Okay. The question number 1 is an icebreaker. It's just to know how many years have you been practicing LCMS-based untargeted metabolomics? A, no experience at all. B, less than 2 years. C, between 2 and 5 years. D, between 5 and 10 years. E, between 10 and 20 years. And F, more than 20 years. Uh, 20 more seconds. Okay, we move to question number 2. Do you agree with the proposed minimum practices for pool QC and evaluating the instrument performance? A, yes. B, no. C, partially. You might want to exclude, add, or revise the practices. As a reminder, these are the minimum practices. Okay. 20 more seconds. Question number 3. Do you agree with the proposed best practices for pool QC and evaluating the instrument performance? Again, A, yes, B, no, and C, partially. You might want to exclude, add, or revise any practices. And as a reminder, those are the best practices, which are the same as the minimum practices, and those are the different ones. Twenty more seconds. Okay. So now we will go to the next part that will be explained by Dajana. Thank you.
Actually, before we open it to the new part, we'll start a discussion of the minimum and best practices that you guys have seen for pooled QC. So in terms of results, you would have seen it on your screens. So for the minimum practices for pooled QC, we had 85% of audience voting yes, and 15% voting partially, so add, revise, or exclude practices. And then for best practices, we had 68% of audience saying yes, and 32% saying partially add, revise, or exclude. So then I would like to open the floor. So let's take first couple of minutes and talk about the minimum practices. So if you wanted to change something, so if you were one of the people that answered partially, would you like to share what you didn't like with us? And we'll have a couple of mobile mics, and the students can come around. So raise your hand if you would like to start discussion, and we'll take comments, questions. Okay, so we have one question over here, or comment.
Well, thank you very much. Brian Gonzalez, Ghent University. I do have several, but I will do it one at a time to give everyone
Okay.
I think my most important one is the definition of pooled QC. Mm-hmm. I'm just curious, because here we mentioned that it's a combination of all biological samples, mm-hmm. which in my case, I do large epidemiological studies. If you have 3,000 samples, I could not think that I should thaw all my samples and you know what I mean. So I think if we are to establish that batches need to have a representation in all stuff, then maybe a QC from batch 1 would suffice, but not for all biological samples.
Exactly, and definitely very good point. And we didn't show you all the polling results that we used, but we did ask what people used in large studies. And there it's completely normal that the pooled QC is not made from all samples, but it needs to be a representative subset that you run in your batch 1 or sometimes batch 1 and 2, things like that. So yeah, 100% we agree with that. And thank you for pointing out about definition. We'll make sure to adopt the wording that it's clear on that point. But excellent start of discussion. I think we had the hand up somewhere here.
Yeah, I wanted to ask something unrelated. So I can see a lot of people are snapping photos, including myself, because this is new to me. Will you be sharing these slides with the best practices and minimum practices?
Yes, so what we normally do is, right now this is a work in progress, so we are taking comments and we will revise it. What we do after the workshop, we generally publish a workshop report where we also publish the slides. So right now, if you go to Metabolomics Journal, there is a report on the 2023 workshop, and it has the full slide deck that was shown there. So we will do the same for this workshop as well. And for now, since you have access to website, you can take a screenshot if you want a kind of reminder of what the practice is. So you guys are the first public that's actually getting access to the guidance. We've shared them internally with mQACC, but you are the first audience where we are getting feedback from the wider community. Okay,
Hello.
Hello. I would like to raise an interesting question here. So what was mentioned that when we are creating a pool QC sample, there is an option either for creating it from the sample itself, so pre-extraction, or we have reconstituted the creation of the pool QC from the sample prepared for injection, so post-extraction and post-processing. And I would like to hear a community opinion on which one is more appropriate, or should we inject even both, because the post-extraction sample will reflect only technical variation, which we can of course perfectly correct, and which in principle should be much more inferior to the one that we have when we are creating pre-extraction pool QCs, and which would be the sequence design. Okay. Because in my experience, it was quite interesting for, like, let's say, small to mid-sized batches, like up to 500 samples, because it really demonstrated what were the prospective flaws or issues, let's say, in our work, and it also gave quite an insight how to optimize further our metabolomics.
Yes, so when we polled about this question, in general we found for biofluids, usually people are creating pooled QC before extraction. That's the most common, followed by post-extraction, and Raquel showed you the results of that. When it comes to tissue samples, it becomes more difficult. So there, either people are doing it during homogenization step or actually towards very end after the extraction as well. So we saw a big difference whether you're working with solid or liquid samples there. In terms of the guidance, we don't want to mandate one way or the other. The idea is you select what's best for your study, but also keeping in mind what you want to control, right? If you want to control your sample preparation with the pooled QC as well, then you need to do it pre-extraction. If you only want to control your technical performance of the LCMS instrument itself, then you can pool post-extraction. So we want to keep this open to different types of studies, different types of samples that we have. Yeah.
Hello. My question is regard to how many times, I understand that I need to inject the QC at the beginning, in the middle, and at the end. But for large sample size, what could be the best number to inject the QC?
So most frequent is somewhere between every 5 to 10 samples. So typically, even if you have a large study, right, you would inject every 10 samples or so, because you want that continuous monitoring of performance. So pretty much you don't want to have a very large time gap between your pooled QC injections. If something happens with the instrument, if there is signal drift or something gets dirty or other issues, you want to be able to notice that. So most frequent is, let's say, around 8 to 10 samples. Okay, I think we have.
Hello. Yeah, maybe I missed it, but do you also have some guidelines regarding reference materials to use? Because yeah, I saw a lot of like QC stuff for this in the sequence, but if I want to know if my method actually works for what I'm interested in, I would have to compare to other labs, right? I can only do that with some kind of reference material.
Excellent. So today we are focusing on pooled QC's internal standard and design of analytical batch. The guidance will have reference material section, but we are not going to discuss that today. Just in interest of time, we could not cover all the topics, but you're completely right. Reference materials are definitely key. So I'll go back quickly to the minimum practices for pooled QC and just see if we have any further feedback from people who selected partial. If there was something they disagree, want to exclude, want to add, is there any further comments from the audience on the minimum practices? I think somebody has a...
Yes, thank you for this very nice presentation. My name is Audrey de Gouelec, and I would like to... I have a question not regarding these minimum practices. So my question is, can you give us any recommendation on the acceptance criteria you mentioned to be used for the QC pool? I mean, you mentioned percentage of RSD, and what do you think the value should be?
So what we don't want to do with mQACC is we don't want to be prescriptive, and we had this discussion yesterday in workshop for lipid met as well. Your acceptance criteria for pooled QC will really depend on the type of application and the kind of differences you are looking at. So if you are looking for very small differences in metabolite levels, if the changes are very small, then you want a very stringent RSD to only look at very well-behaved metabolites, right? If you're looking at very wide changes, like if you're looking at changes that are tenfold, then you can use a wider acceptance, 20, 30%. So we don't, for the consortium, we don't want to propose acceptance criteria because this will really depend on the purpose of the study, exact application, and what exactly you are trying to do. But generally, when we polled about that metric, most of the people were between 20 to 30%. So it was about, I think, 60% of people were using one of those two numbers.
Okay, thank you very much.
Hello, Diana. Here. I would have a follow-up question or comment on the pulling of the QC prior or after extraction, because so far I have been doing it prior to extraction, as you mentioned, and I think it's the most standard in the community. But what I have faced many times, even if you don't have a super large number of samples, like if you have 300 samples, you would inject, let's say, 50 times, right? So if you prepare different replicates of the QC, it might be that, I don't know, you have a slightly higher relative standard deviation for one. Yeah, it's the extraction variation that you are adding up. And so far, as I see it, we are using the QCs for basic post-analytical, so like to control for features and filtering, variation, and so on. So from my perspective, it makes more sense, I think, to pull the QCs afterwards, because then you are really sure that in all the vials or in all the injection replicates that you have, you really have exactly the same thing, and you can control better for the instrumental variation. So I want to hear your take on that, if that makes sense also to you, because with the prior extraction, you have the variation from the extraction and from your instrument, right, that you cannot detangle. So that's how I see it, and I want to hear your take on that.
So now I will say my personal opinion and what we do in the lab. I agree with you, and we use pooled QC to monitor instrument performance. So we normally pull it post-extraction, and we monitor our extraction using internal standards across all study samples. So for me, that way I know if my variability is coming from either extraction process, from the instrument, or from both. So that's how my lab does it, but as I mentioned, mQACC is leaving it open. If you prefer to do pre-extraction and use pooled QC to monitor that and you don't use internal standards, that's perfectly okay too. So as long as you know what you are monitoring and what's reasonable acceptance criteria for the way that you are doing it, that's fine.
Yeah, and just to add, also another problem that I see from prior to extraction is that, for example, in our lab, many times we have like, I don't know, serum samples from premature babies that you have 30 microliters, and then, of course, you have a higher volume after extraction, so it's just easier to pull afterwards. So, yeah.
Yes, my lab faces similar. We work a lot with my sample, where we also have very limited volumes, so I 100% agree. Good, so I think we'll take one more comment here, and then we'll move on to the next. But if we have time at the end, we will continue the discussion at that point. So we'll take last comment here.
Yeah, thanks. So I wonder what happens if you reject an analytical batch, because then you have to probably check re-injection stability, or you have to rethaw your samples. So what's your advice on sort of these kind of things? So do you validate in front whether you can freeze thaw multiple times or re-inject your samples?
So I think that's, again, going to be very sample and study dependent. So I don't think we can provide guidance. In general, you have to have what's your acceptance criteria for a batch, like will I accept this batch as run or not, right? If the batch fails, then it really depends on the study, right? If you're dealing with pressure sample where you already used up your sample, you may not be able to rerun it. You might need to go to new collection. If you know that you're looking at metabolites that are stable to freeze and thaw, then you might be able to rerun it. So it's really going to be study dependent. I can't generalize because it's really going to sample and study type are going to dictate that.
Thanks.
Okay, so I think excellent discussion. Maybe I'll open for one or two comments on the best practices. So there we had more disagreement. So we had about a third of the audience wanted to change something about the best practices. So I'll open it for one or two comments at this time. I think I saw a hand up here. Did you have? Yeah. And I'll show the second screen as well.
Yeah, I was looking at the pre-concentration. Oh, there it is. Yeah. I'm just curious about that because, of course, when you pre-concentrate your pooled QC, you are doing something to that, to that data point that you don't do to anyone else. So that actually introduces more variability. So I'm not quite sure whether doing a pre-concentration of the pooled QC would actually affect the linearity data yourself. It's already questionable what is linear, right? Mm-hmm. But what we found, and don't quote me on this, what we found in our lab to work is instead of pre-concentration or diluting the sample, we just change the injection volume. So we just inject 20, 15, 10, 5, and then it works somehow. But I don't know if it actually works in the same way.
No, this is an excellent point, and yes, you can vary injection volume and look at that. In terms of and we can revise the guidance to reflect that as well. In terms of pre-concentration, there is a nice study by Matt Lewis. If you talk to me afterwards, I can point you to the paper where they actually also pre-concentrated pooled QC samples and then did dilution series. Because, right, if you only do dilution series, then you are looking how your signal changes below the pooled QC levels, right? But you don't have any sense of what's happening if the signal is above, right? So the idea of the pre-concentration is to look both below pooled QC signal and above. So he has a nice paper where pre-concentration worked and they could look at signal linearity. But yes, changing injection volume is an easy way to do it if you can span a large enough range with your volumes, right? Then that will work as well. So yeah, excellent point. Good. One last comment for best practices. I think I see a hand over there.
Hi. I think these are all super awesome. The question I have and the addition of best practices is that are you planning on adding anything like a template or a table or something that people can include into their SI to like report the best practices that they have and they haven't used? Like if they chose to pre-concentrate or do whatever, because my lab has done a couple of meta-analyses, and one of the big issues that we found is we're looking at how are people doing things, but then there's such variation in the way people are reporting that it's very hard to evaluate. Let's say in 10 years after you've introduced all these best practices, how do you look back at the publications that have used them and how do you evaluate what worked and what didn't and things like that?
Yes, no, that's an excellent point. And the reporting side of things, we've seen a lot of issues in literature. So mQACC did a scoping review of 2021 literature, and we encountered exactly what you're talking. It was really hard to tell from a paper what people did. And 5 expert metabolomics people read the paper, and sometimes we disagree how we interpreted what was said. Did they do it pre-extraction? Did they do post-extraction? How frequently they did their injection? So it was very difficult from current literature. So I will show at the very end of today's workshop. So mQACC has a reporting standards task group. So they've already published a paper that actually has a template of reporting. So I'll have a QR code for that. And there is also one presenter from that task group, and they will have a poster as well. So you could also come and talk to them and visit their poster. So yeah, but the reporting is definitely a huge issue. And as we talked also yesterday in the lipid met workshop, I think kind of going forward, what Peter Dorstein was saying was to move towards data-readable reporting, right? So computer-readable type of formats for reporting QC data as well. That would really help the field move forward and really have all the QCs together with the full data sets. So I think that's where we want to go in the next decade, but I think we all need to work together together.
Thank you.
Great. So I think we'll stop for now in terms of comments for this topic, and we'll move on to the next topic. But then if you didn't have a chance to tell us your comment, you can find us also after the workshop. So don't be shy, or email the mQACC email and let us know your thoughts. So now then, let's switch gears and let's talk a little bit about the use of internal standards in LCMS, untargeted metabolomics. So if you look at the evolution of the use of internal standards in untargeted metabolomics, the use is a little bit haphazard if you look historically, right? The idea was that it was not possible to pick internal standards that will be representative of the entire metabolome, and generally the movement was towards using pooled QC approach to monitor repeatability and technical performance. But if you look more recently, I think we can see more widespread use, especially in lipidomics community, but also increasing in metabolomics community. And there is some really nice tools that are emerging, for example, from different vendors, where they can also monitor internal standard performance on the fly and flag any issues with the run and things like that. So I think this field is really evolving. We are also finding that use of internal standards is really important for larger and multi-batch studies. So if you were here for the nutritional workshop yesterday, they were talking about creating a specific 30 internal standard mixtures in order to harmonize across the labs for that periodic table of food initiative. So I think generally we are moving towards more prevalent use of internal standards. And I mentioned also example in my lab where we use it as a monitoring of extraction across all study samples. So then if you think about selection criteria for internal standards, right, the main idea is it has to be something that's not present in your sample matrix. So most commonly it would be either isotopically labeled compounds or some kind of exogenous compounds. Less frequently it can be an isotopically labeled extract, so there are labeled yeast, labeled E. coli, and so forth extracts that can be used that are more complex internal standard materials. And then if you're thinking about characteristics of these different internal standards, we really need to think about physicochemical properties and try to capture some of the diversity that we see in metabolomes. So in terms of their polarity and retention behavior, ionization mode, so to be able to have good internal standards for both positive and negative electrospray ionization, a wide range of M/Z, and wide range of chemical diversity properties. But then, of course, we have to consider practical considerations as well. So things like availability and cost, what the sample type and matrix is, and what's the purity of the internal standard that's needed. So the selection of internal standard by necessity has to be method dependent. So a set of internal standards is not going to work for everything. And then in terms of the number, generally when we polled for this question, we saw that it was a handful, most frequently I would say less than 10 internal standards used per studies. And this is just an example of an internal standard mixture used in one of mQACC members' labs. And you can see here, the idea is, right, we are trying to cover the entire chromatographic space and have some variability in terms of chemical diversity of the compounds they are looking at. So this was, I believe, for a Helix type method. So then, if you look at our best practices for internal standards, so what we are proposing here is if internal standards, so we are not mandating that they have to be used, we are saying if you are using internal standards, it needs to be reported clearly which internal standard, supplier, catalog number, what's the concentration, and what's the purpose that you are using internal standard for. So the purpose can be something as simple as retention time locking to get retention indices. It could be something like checking the extraction quality and so forth. So it's really important to specify purpose because not all labs use it for the same purposes. And then if you're using isotopically labeled internal standard, which isotopes are labeled and level of labeling should also be defined. Then the next practice is, if possible, this real-time monitoring of internal standards can be very useful to detect problems in analytical batches as they are occurring. So these kind of things can be anything from missing vial, poor injection or air in injections, or degradation of LC-MS performance, such as signal drift, retention time drift, and so forth. The next best practice is we don't recommend using internal standards for semi-quantification of compounds unless they are really structurally related coeluting type of compounds. And then continuing, here we all differentiate that internal standards can also be added at two different parts of the workflow, right? We can add them pre-extraction, in which way they will monitor our extraction processes. And there we are saying if you are using them in that way, then they will highlight technical errors that occur during sample preparation and analysis, and you need to have predefined criteria whether to accept or reject your sample results. If you add internal standards post-sample preparation, then this will highlight technical errors during analysis only, and again, you need to have predefined criteria by which to accept or reject a particular batch or sample. The next best practice is a reminder that if you optimize your internal standard selection for one matrix, it's not necessarily going to work for other matrices. You really need to go back to the drawing board and re-optimize. You might be able to reuse some of your internal standards, but not all of them. So you really need to check for that selectivity, concentrations, and so forth. You need to go back to optimization. There, you need to verify there is no interferences and that the concentrations are suitable for that particular matrix. We also recommend running at least one pooled QC sample that hasn't been spiked with internal standards, and this gives you a check within that study that there isn't some new unexpected interference from your study samples that could interfere with internal standards. And then last best practice is to run at least one internal standard only sample in order to be able to assess matrix interference with internal standards. And then if you go to our minimum practices, there we are very simple. We are just saying if you are using it, tell us what you are using, what concentration, and for which purpose that you are using it. So, to show you a few of the polling results that we obtained when we talked about internal standards in previous interactive forums. You can see here when we ask the community what type of compounds they're using as internal standards, you can see a large number is using isotopically labeled internal standards. And then in terms of mixtures, both in-house and commercial mixtures about evenly split in terms of use, and about 30% is using unlabeled but not present in particular specimens internal standards. And you can see about 12% is not using any internal standards. So we have quite high uptake of the use. So this leads to the minimum practice that we had. So minimum and best practice. If internal standards are used, tell us which ones and why you are using them. And also to the best practice regarding re-optimizing the mixture and concentration of internal standards that you are using for each matrix of interest that you are working on. And this one also leads to best practice to run at least one pooled QC to verify that there is no interferences, and to run at least one internal standard to verify there is no matrix interference with internal standards. In terms of the experimental design and this idea of either spiking pre or post, as we mentioned, so if you spike pre-extraction, then these would be called in some communities recovery standards, and they will highlight both errors with analysis and sample preparation. And if you do this post-extraction, it will highlight only errors during the analysis part of the workflow. And then just to show you some of the examples of how internal standards are being used by community. So one way is looking at retention time drifts or calculating retention indices. Another way is looking at signal response, so monitoring is everything working okay with a particular study. Another way, especially if they are spiked post-extraction, could be to monitor matrix effects. So for example, my lab works with the normal and highly lipemic samples. So we use internal standards to look, do we have different matrix effects between lipemic and normal samples. You can look at things like mass stability, retention time drifts, and then they can be used for semi-quantification. This is more in a lipidomics community than a metabolomics community. So then in terms of best practices, this is where the real-time monitoring practice comes in. If you can monitor during the run, it can help you address problems as they occur. And this also leads to the recommendation that we don't recommend their use for semi-quantification unless they are correlating with an analyte of the interest. And then for the last examples, I'll show you some example metrics that can be used when you are looking at internal standard evaluation. So this is an example from an mQACC member lab. So you can see here one of the internal standards they're using is phenylalanine D5. So you can see in the table they're looking at things like area, retention time, M/Z, and accuracy of M/Z. And you can see here there is one sample highlighted in red that is below their acceptance criteria. So this is telling them that something went wrong with this sample, and this is a sample outlier, and this is going to be excluded. And then you can see they can calculate RSD on peak area and have acceptance criteria for that. So in this case, it was 12%, and it meets acceptance. They can look at RSD of retention time. In this particular example, 0.3%, again, meets acceptance criteria. M/Z values, you can see, are very good and generally less than 2 ppm, so everything is working well on that. And then you can also check MSMS spectra and make sure everything is working well in terms of MSMS fragmentation. So this is just an example of how you can use internal standards to help you evaluate the quality of your study. And the important part is establish your cutoff criteria so you know what's acceptable and what's not for your methods and the variability that you are seeing normally. And then we ask community whether they use internal standards to either accept or reject individual samples. Like in the example I showed you, there was one sample that had very low internal standard levels and was rejected as sample outlier. So you can see about 58% of community is using internal standards in this way. And then we ask if they're using internal standards to accept or reject entire batches, and about a third or 35% of community is using internal standards for that purpose. So overall, what we found and what we heard from the discussion is, of course, if we were all using common internal standards, that would be the best. It would lead to better intra-lab and inter-lab comparison, similar to the comment we heard about reference materials. However, because we're using plethora of different analytical methods, then it may not be possible to have exactly the same internal standards for everyone. So at the moment, we are focusing more on metrics. I think if we can harmonize metrics and how we are using internal standards, that's the first step before actually harmonizing which internal standards we are using. So I think as a community, we have some work to do on that part. So then to sum up this section, so we think that use of internal standards within metabolomics workflow is increasing. They evaluate data study quality beyond what you can do with pooled QC, because here now you're looking at your every study sample, right? So they're giving you additional information beyond what you can get with pooled QC. And in general, we are seeing lack of agreement on how to use internal standard and what metrics to apply and what's best there. So now let's go back to polling questions. So if you guys can open your polling up. And I will ask you as the first question, do you agree with what we are proposing as a minimum practice for internal standards? So the answers are again same as before. Yes, no, or partially. And I'll refresh your memory. So for minimum practices, we only had this one. Tell us which internal standards and for which concentration or for which purpose you are using them. Is everyone able to access the poll? Okay, I'll take silence says yes. Okay, maybe 20 more seconds. If you haven't had a chance to answer, please let us know what you think. It's okay if you disagree, you can let us know as well. We really value the feedback. Okay, so I think we are going to close the poll for this one. And then we are going to go to the next question, which is going to be, do you agree with the proposed best practices for internal standards? And your answers are again the same, yes, no, and partially. And I'll refresh your mind in terms of best practices. I'll leave these ones up for a minute, and then I'll switch to the next slide as well. Okay, and this was the next set. You also do have them on the website that Callum shared if you want to refresh your memory on your phone. Okay, do you need more time or it's good? Okay, maybe 20 seconds. If you are still thinking about it, we'll give you 20 seconds and please answer. Okay, so I think we'll close the poll now. Okay, and then maybe I'll ask my colleague to share the results. I don't have my phone with me. So what was the result for minimum practices? Okay, so I think we had very good agreement for minimum practices here. 93% said yes, 7% said, I think, partially or no. So I'll open it maybe to 1 or 2 comments maximum on minimum practices. For people who disagreed, what was the issue that you had with this practice? Anybody want to share with us? So it's not mandatory to use them. It is good practice. What issues did you see with this statement? Anybody? Okay, if there is no comments on that one, if you want to talk to us offline, you can. Don't be shy. And then I'll go to the best practices. So there we had 77% agreed, and 23% said partially. So about quarter of the audience wanted to change something. So who wants to share with us what they wanted to change? Okay, we have our hands up here.
Thank you. Yes, maybe it's in the next slide, the point regarding to run at least an unspiked or a QC pool without the internal standards spiked in. I was wondering how you put it together with the recommendation of the QC pooling strategy. So if you spike your internal standard before extraction or after extraction, maybe you lose the chance of having an unspiked QC pool. I was thinking that just maybe how to reconcile the 2 recommendations. I did not give it a very deep thought, but maybe, there might be a way, I guess, but maybe it's just not so straightforward. That's the only comment I have.
Yeah, so I think very valid comment. So I think, that would work if you do your pooling before internal standard is added, right? If you do pooling after internal standard is added, then this would be a difficult requirement or suggestion to fulfill. In general, I think most people would be pooling before internal, so you are treating your aliquots of the pooled sample as if they were study samples, right? So you pool them, then you aliquot them, then they become kind of same as your study samples, and then you add your internal standard and so forth. So I think for that workflow, it would work well, but you are completely right. We can add a note of clarification. If you spike internal standards first, this is not going to work, but it's also best practice, so it's not mandatory. So if for a particular design you are not using it, that would be okay as well. But excellent point. Okay, we have a hand up here.
I have a short comment. So in my experience, when we use the word internal standards in the targeted community, people assume that you are quantifying something. And just to avoid this misunderstanding in the untargeted metabolomics, how about using technical internal standards just to separate the internal standards which are used in the targeted world? So that's just my comment.
Okay, excellent comment. Yeah, we are struggling a little bit with nomenclature as well to make sure we are consistent with, and I like that idea, so we will discuss and get back. Good, other comments or changes you would like to see for these best practices? Okay, I think we have a comment here.
It's just slightly connected to the previous comment. It's not described in many of the papers how they have used. And that is the main missing point. Okay, they describe, they use these internal standards, but how? Around 80% of the papers that I have read is not described exactly. But I would be happy to see that many of us were reviewing papers asking this from the authors. That would, I think, enhance the quality of understanding. Thank you.
Yeah, no, we 100% agree with you, and that's why in minimum practice is really that purpose is highlighted, what they are used for, that has to be included. If you are using standards, you have to tell us why. I think I saw a hand briefly here.
Yeah, so I also would like to highlight, let's say, less widespread use of internal standards, I mean, for metabolomics community, which is quite popular in exposomics or environmental people, and this is namely a mass recalibration using internal standards. So maybe this will also be some time point to introduce this workflow, because in fact when we are working with a mass spec, especially with, let's say, lower or medium grade, we need to recalibrate our data to provide the best possible quality. So if this workflow would be discussed and introduced, and yeah, this would be quite a good thing, I think.
Okay, good point, yeah, that we didn't show as one of the example uses, but you're completely right, for the locking, for mass calibration, perfect. Good, I think I see one hand up here, and then we'll move on to the next topic.
Thank you. So I want to see if, in terms of the lipidomics, if we have a class-based internal standard, would it be appropriate to using it to quantify, or semi-quantify, I would say, the same classes species?
So this is a widespread practice in lipidomics, and if you come to my talk tomorrow, I'll show you some results, how much the choice of internal standard impacts the quantification that you do. So I think the answer is it's complicated, right? I think the practice emerged when the predominant workflows were direct infusion, right? When all the lipids were in the source at the same time. So at that point was maybe more applicable. Now as we moved more towards reverse phase method where internal standard is not coeluting with all the lipids from the class, it's becoming more problematic. And even just which standard you select has a really big consequence. So if you come to my talk tomorrow, I'll show you lots of results on how difficult.
Yeah, because some endogenous sometimes considered to be exogenous, then we detected in some samples it became endogenous later. So it's just hard to define sometimes.
Yeah, no, this is definitely a tricky point, and I think this is where the two communities diverge a little bit, but I think there is a pull also to bring, to understand better this choice of internal standard in lipidomics. So yeah, excellent point.
Thank you.
Great, so I think we'll stop here in the interest of time, but if you have more comments on this, come find us after the workshop and at coffee break. And now it's my pleasure to introduce our final speaker of the session, so Dr. James Harynuk from University of Alberta, and he's going to tell us about the design of the analytical batch in LCMS-based untargeted metabolomics.
All right, thanks, Diana. Good morning, everybody. I'll be continuing on talking about the analytical batches. Now, first, as we get started, we should define what we mean by an analytical batch, and that's, of course, any set of continuously analyzed samples. So you prep them and put them all on the rack and press go and let them all go. And when you're designing this batch, you have a lot of things to think about, including the size of the batch, how you're organizing your samples in the batch, and the types of samples that you're going to include. So things like blank study samples, technical replicates, pooled QCs, et cetera, et cetera. And we have a reference, or a couple references for this on the screen right here. Looking at the best practices that we have here, we want to design the order that we run our samples, that we avoid any biases. So in other words, we kind of want to randomize how we run our samples and ensure also that our study samples are bracketed by pooled QC samples and other QC samples. Quite often, it's a good idea to have class balance blocking, and I'll have an image that shows what I mean by this later on. This just also helps avoid any biases in the results. With LCMS, you want to make sure that you're equilibrating your LCMS system and conditioning it with a pooled QC or some other kind of throwaway sample, basically, that lets you equilibrate the system so that when you start running your actual samples, the system is stable and ready to go, the column is well behaved, et cetera, et cetera. And again, I have some data that I'll show about that in a few slides. We want to make sure we include appropriate blanks, including solvent blanks. We want to be able to detect carryover process blanks to detect any anomalies that show up during our sample preparation or sample collection, et cetera, et cetera. We want to make sure that we can evaluate the effect of injecting blanks between study samples while we're doing the method development. And again, I'll show data about this in a couple of slides, but your blank samples can potentially interfere with the samples that come after them in some analyses. So you want to make sure that you check verify is this a problem or not for my particular study while you're doing your method development. Continuing along, for large-scale studies, we need some kind of long-term QC that lets us evaluate inter-batch reproducibility. This is particularly important for studies that are, longitudinal studies with thousands of samples spanning many, many years of sample collection, et cetera, et cetera. Generally speaking, what we're recommending is to use blanks at the beginning. Ensure your instrument is clean before you start using it, and at the end, ensure the instrument is still reasonably clean. You don't have a lot of carryover from previous samples in the batch. One thing you have to do during your method development, again, is determine a reasonable batch size, and this will, again, depend on how long your instrument stays stable, and it will depend on other factors as well. You need to include some long-term QC samples to allow for data quality comparisons across different studies within your lab or across different labs so that you can compare your results from this study today with a study that you ran 2 years ago and a study you're going to run in another 2 years to make sure that all those results are comparable. So in terms of the minimum practices being recommended, as a minimum, people need to be cognizant of the run order and to randomize their samples as they're developing their method. Again, as a minimum, use sample randomization with blocking when and where possible or where it makes sense to do so, again, to minimize biases in your results due to the run order of your samples. Again, equilibrate your LCMS system and ensure that it is all stable before you start running your actual real experimental samples. And again, include a collection of blanks for detecting your contaminants and detecting anything that's gone awry while running your samples. And again, as a minimum, people really do have to evaluate the effect of injecting blanks and that while doing their method development. So here's just a couple of figures that I have to show a couple of things what we're talking about here. So here's an example sequence with blocking. So on this sequence right here, we're starting up here with, again, some blanks, and then we run a QC, and we just keep running a few QCs to do our system conditioning. And in this case, during the method development, we've decided, okay, we have to run 8 QCs to stabilize the system prior to running actual samples. We then run a few pooled QC samples at the beginning to get an idea of what the reproducibility is when we're running our actual samples. And then here we have our blocks. So I'll have, block 1, block 2, block 3, 4, 5, and 6. And what you'll notice is in each one of these blocks, I have one sample representing each class. So here I have 4 classes of samples. In each one of these, I will have one of my samples from each one of these different classes. Which sample I have from any one class is randomized. So here I have, I've got my SRM and then 3 classes, sorry. But here I've got, from the diabetic sample 1, or class 1, but sometimes they run at the beginning, sometimes they run at the end. The order is all randomized, but within each block, there's one from every class that's there. Between the classes, I have pooled QCs, and when I get to the end, again, I run some more pooled QCs. I run a process blank. I run my system suitability QC to show that the system is still behaving and it's still under control, and one more solvent blank at the end. So again, the minimum practice is to design the run order to avoid our bias, so that's where the randomization comes here, and ensure that our study samples are bracketed by pooled QC samples. We've got the randomization within the balanced blocking, and here it makes sense for this particular study design. And again, at the beginning, we're equilibrating our LCMS system. So if we look at blanks, there are a lot of different blanks out there and different ways we can use blank samples. These were defined earlier, but I'm just going to touch on them again here because this is where they become kind of important. We have our solvent blanks, and those, or we can have our system blank, which is basically just running the system with no injection. So that's where we're going to be looking at what's going on in the system, what's going on in the solvents that we're using to run the eluent for our LC system. Then we'll have a solvent blank or a reagent blank. This is a solvent reagent blank, basically everything we use to prep our samples other than the sample itself. So in this case, we're going to be looking at our extraction solvents, any reagents, any derivatization reagents you might use, enzyme mixtures, whatever. All that stuff gets used here to see what those different things look like. And then the process blank, which is where we sort of put everything all together except the sample, where we run our reagents through the whole extraction process to see what the blank from the entire process looks like. And again, just sort of to differentiate these guys here a little bit, this kind of solvent blank or reagent blank would be like just the solvent on its own, or just a reagent diluted and run on its own, not a blank, not like water carried through the entire sample prep procedure. So in terms of data from the study from before, the data that we collect from the survey, looking at what purposes do people inject a blank sample. Most people use them to look for contaminants for processing and to look at carryover. Some people are using them to look for cross-contamination between study samples. About half the respondents picked that. And then a few people were using them for other processes. So as a minimum practice, again, include appropriate blanks, solvent for detection of contaminants, et cetera, et cetera. The next polling question that we have is, when do people run a blank sample during an analytical batch? And we have, at the beginning of the batch, at the end, before each pooled QC, after, more frequently than every 5th sample, between every 5th and 10th, less frequently than every 10th, and I don't use blanks at all. So, I mean, the good news is people are running blanks. And again, as a minimum practice, we're suggesting to evaluate the effect of injecting our blanks between study samples during the method development, so that we know if that's going to impact the conditioning of the system. And as a best practice, using blanks at the beginning and the end to ensure that your instrument is clean before you start using it and to detect any carryover once you get towards the end of your batch. Now, just looking quickly at choosing when and where to place your blanks and this, if we have a sequence right here, the questions are, do we put blanks at the beginning of a batch? Do we put these blanks after a few QC injections at the end of a batch? Or do we put them in between, if we run blanks in between samples? And the recommendations, again, are to run them at the beginning, excuse me, and at the end, and potentially run some after running some QC injections, and to evaluate the effect of running the blanks between samples. With some LC systems, this may not be an issue, and with some, it may be an issue, right? What you're trying to assess here is, am I disturbing my column and the column chemistry by running blanks? So the blank placement depends on your sample matrix, how much deconditioning happens when you run a blank, and the analyte properties. And this deconditioning protocol needs to be determined for your own methods. And again, as a minimum, check out what happens if you run blanks between samples and if it causes a problem or has an impact on the conditioning of your system. And again, best practice, use the blanks at the beginning and the end of your batch. So here's just a little bit of data to see what happens if you're running blanks in between samples. So we have two different experiments that were done here with a bunch of QC samples, and in case A, we ran, well, not we, this wasn't my lab, but in case A, there were a collection of blanks that were run at the beginning, then there were a bunch of QCs run, and then a bunch of blanks run together sequentially, and this was repeated over and over again. In case B, we had just one blank and then a bunch of QC samples, and then one blank and a bunch of QC samples. And this was done with both urine and plasma samples. And if we look at the data from here, and honestly, as a GC guy, I found this initially kind of surprising until I stopped to think about it a little bit. But what we can see here in A, this is where we ran a lot of blanks, we see the response for, this is looking at where the samples project in principal component space on PC1. Under normal conditions, your QC should project somewhere up here. At the beginning, where your sample was or your column was deconditioned, we see everything is biased down. On this one here, looking at PC2, again, samples should project somewhere around here. This looks reasonable, but the ones at the beginning, they're projecting off in the wrong direction, again, because the chromatography wasn't stable when you did this, and or the mass spectrometry, I guess, as well. Same thing here with plasma. If we run this, the first samples here project in kind of a weird place, and we also see the ones here where there's just a lot more variation that's happening with the intense deconditioning as compared to the mild deconditioning where the system stays much more under control and the results are much more reproducible. So again, oops, sorry, let me back up for a second. Again here, this is just one thing to be cognizant of while you're developing your methods and stuff like that, so that you check it out. Is it an issue? If it is a problem, don't do it. If it's not a problem, you can put blanks in between your samples and it's no big deal. Looking at other polling questions we had, the maximum size of batch that people would continuously analyze, most people seem to be in the sort of 50 to 100 injections as a batch. One of the things here you want to just do, and that we're recommending again, is determine a reasonable batch size during your method development. And to quantify how you can decide what is reasonable is just looking at keeping your signal intensity plus or minus 20% for your QCs. There are a variety of things that can limit the size of a batch, and it could be your sample prep, it could be the runtime of the batch, instrument time, stability of the instrument, and work days of the people who are running your samples. So again, during the method development, just determine a practical batch size that works for your lab. Most of this will be determined based on the instrument and the assay that's being done, and again, it needs to be determined during your method development. So just to sort of sum up some of the high points here, again, use appropriate QC sample types when you're designing your analytical batches, including blanks, pooled QCs, long-term QCs, etc. Use randomization and blocking to minimize bias. And those are the two main takeaways from our recommendations. Moving now into the polling questions. Question 6 is, no surprise here, do you agree with the proposed minimum practices for the design of an analytical batch? This question should be live. Yes, no, and partially are the answers that you have at your choices. And just to remind everyone what the minimum practices are, here they are right here. Okay, we'll give about 20, 30 seconds for people to finish up. Okay. And then moving on to our next question, which would be question 7. Do you agree with the proposed best practices for design of an analytical batch? And again, here is the first list of the best practices. And then that gets continued on with 6, 7, 8, and 9 here. Okay, we'll give it about 20 seconds and we'll wrap this up. Right, and I'm hoping they can push the results out in a second so I can see what's there. Okay. All right. So, and anyone following along on your phone, you can see this as well. There appears to be, for 88, 90% of people agree with the best practices and the minimum batch. But there is a small number of people who are partially in agreement, and there'd be something they would like to see changed. So if there are any comments from the audience about what they disagree with or would like to see improved or modified, just stick up your hand. Someone will bring a microphone around to you.
Yeah. Sorry, again, not fully related to this question. Could you clarify what you mean by system suitability test in your queue? Because you had a slide where you had system suitability sample, and
yes.
it followed blanks for some reason. What is that exactly?
The system suitability sample, in this particular example, I don't remember where that one came from. I don't know what the example was. Do you remember? I'll let Diana. I mean, it might have been your lab. Not your lab.
It's not my lab. So for system suitability sample, it can be either a mixture of standards of a known composition or a mixture of standards spiked in your biological sample, and it's run at the very beginning to test whether your system is ready to start the batch. And usually as part of system suitability testing, blanks are run. So that's why you are right. You saw blanks and system suitability sample. Both of those are run together. Blanks to test for instrument contamination before you start, and system suitability to check retention time, M/Z, instrument stability, and so forth. So yeah, they're usually run back to back.
So it's like chemically pure compounds.
Yes, so it could be chemically pure compounds, or it could be pure compounds spiked into a biological or environmental matrix. Different labs use either simple mixtures or complex samples or both. We had about, I think, 30 to 40% of labs use both. They have one authentic standard mixture and one more complex sample as well.
Hi, sorry, it's me again. Just with my very quick, I have the impression that the best practices list and the minimum practices list look very similar. Am I wrong to assume that?
Whoops, wrong way. Basically, the first 5 are the same, and then for the best practices, it would be add on these other 4 things.
Maybe this is just a bit of a wording issue, but when we say minimum, of course, we defined it a while ago. I think it has to be like minimum. So we should not put there like things that are applicable or not. I agree they can be best practices, but to put them as a minimum requirement as well is probably too stringent. My first point. If there's a lot of leeway in it, can I see number 1 to 5 again, for example? Like using class balance blocking when possible. That's a best practice, I would say, but not a minimum standard because it's when possible, right? That's my first point. My second point is actually I'm quite curious the amount of evidence we have on the difference between having to block your balance than comparing to just making them all random. I think that the risk is more theoretical than it actually is, but the practical implication of that is actually quite big as your sample size becomes bigger. So that might be something we have to consider. If you have thousands of samples and you need to, especially in a biobank setting where you have to put your samples back to originally where you put it from, which shelf, which box, which arrangement, it can be a very practically challenging thing for a minimal theoretical bias that we might face.
I'm right now trying to remember where I've seen data. It wasn't data from an LCMS context, but I have seen data for sure, where blocking is incredibly important. Especially if you have if your instrument does drift, and you don't pick up on it, then you will see, if you run all of your sample type A at the beginning, all your sample type B in the middle, all your sample type C at the end, and your instrument drifts over that time, and you have no way to detect and or correct for it, then you're going to have a problem, right? I think that's where this is coming from. And I can't remember where the original data set where I saw this came from off the top of my head.
Just want to point out your example is comparing block versus not randomizing at all. Of course, if you run AA together, B together, that's no randomization at all.
Yes.
So my question is whether just do randomize just do a non-biased randomization that you can, or whether you really need to make sure that, if you have 25 variables that you collected, that would be challenging. So if you have a small sample size, that's easy. If you have, let's say, an epidemiological study with 1,000 study, it can be difficult. I'm just saying. That's why I'm saying it can be a best practice, but to put it as a minimum is probably too stringent.
I think that might be where it says where possible as well, right? Because I think when they put all this together, when all this was assembled, again, it was it isn't always possible, right? It's just like with the pooled QC. If you've got a study where your samples are coming in over a period of months or years, you can't have the samples at the end pooled with the samples at the beginning if you're going to start running samples and that before the study finishes, right?
Yes, I have a question on the system suitability because we established a mix of standard about 3 months ago in our lab, and I remember at the time we were asking ourselves, like, for example, for the same instrument, we have, 4 different columns that are run across the methods. And we were wondering, should we use this mix of standards each time on each of the columns to also control, for retention time drifts and so on, or should we just rely on the pressure? Or instead of that, should we have one specific and short column that we have a fast method and we just run the system suitability always with the same column before running your batch on your application? And we decided for the second one because we have more data on the system suitability to kind of track relative standard deviation or whatever you need to track. So I want to know if there is any recommendation on that and what is your practice, let's say, at your lab.
So just to clarify, so you're saying basically you'd run your system suitability test with one column and then you'd change the column to run the rest of
Exactly. So in the end, you don't have any information on the, let's say, the performance of the column you're running at the moment. We just rely on the pressure. And of course, we run other, let's say, spiked QCs or things like that because our system suitability is just a mix of standard and solvent. It's not a spiked sample or a spiked QC. So that's what I want to hear from you. Like, is there any recommendation? Should we change something related to that? What would you do?
Yeah, so I think the idea between system suitability is it should be the exact system you're going to use for your study. So it should be the exact column you're using for your study. And if you're alternating between 4 columns, then I would do injection on each of the 4 columns that you are alternating throughout the study. So I don't think you can use a different column for this. I don't think it's a good practice.
Okay, great. Thank you.
Hi, here. I have a question for when you have like very large studies and you have multiple batches. What's your recommendations for the inter and intra QCs and also the dilution PBQCs as in your running order? Because of course we want to maximize the number of samples per batch, but we also want to have all the quality control checks within each batch, right?
Yeah, so for that, so we'll have separate sections on the inter-study batch, QC, and reference materials. But definitely in terms of requirement, you should run either a long-term QC or reference material or both as part of each individual batch. So each batch should have those injections. Personally, we like to do at least beginning, middle, and end for those long-term QC type of injections to have at least kind of triplicates at a minimum to have an idea. But if you can afford and your methods are short, you can always add additional injections as needed. But I would say my recommendation, this is from my own lab, is like beginning, middle, and end, and gives you enough control over what's happening in each of the batches when you try to align things across the batches.
And for the dilution of the QC?
Dilution of the QC we generally run at the end of our batches. So after the last pooled QC that you're going to use to check your repeatability, after that we do the dilution series in my lab.
Okay, thank you.
Yes.
And I think this will be our last question right here.
I have a short comment on the blanks. I think they are really important, and when you show it in the sequence, so you have one blank and then 3 QCs, and at the end of the sequence, 3 QCs and 1 blank. I think probably should be balanced. 3 blanks, 3 QCs, just to really know what is in your blank. And my the other part of the comment would be, so I think in the untargeted metabolomics, people kind of go for the speed and they apply kind of the maybe similar thinking from the targeted metabolomics, where you have the internal standards which can catch the variation from sample to sample and the carryover. And in general, I think if you have in the untargeted metabolomics a method which deconditions your column, or which kind of if you did not equilibrate column long enough, then you will have the carryover problems, and this might be especially a problem in the large epidemiological studies where the samples are not similar, where where you can have some outlier person with the very deviated metabolomic profile or high drug, and if you don't wash your column enough or you don't equilibrate enough, so that kind of it's not the same condition, not in the same condition before every sample, then I think the data analysis becomes much more complicated and you can extract much less from your data. So I think that maybe in the best practices, like in the addition, maybe the blank should not be influencing. So if you inject the blank in the middle of the sequence, you should not influence the intensity of the other samples. Thank you.
Thank you, and I think in interest of time, we'll stop here. And just to wrap up the session, thank you for amazing discussion and feedback. And in terms of the next steps for the living guidance, so we are currently working on the remaining topics, some of the which we touched today, system suitability, reference materials, and so forth. We finished information gathering for all, and we're in process of writing the guidance and launching the full website and guidance and publication. And then we are also working to expand the guidance. Everything we talked today was LCMS focused, but we want to expand it to NMR and GCMS. So here I want to call on you if you use either GCMS or NMR. We are currently collecting practices from community for these two technologies. So GCMS QR code on the left, NMR on the right. Please participate. It really helps us to know what you are doing, why you are doing it, and what good practices you have developed over time. And also feel free to share with colleagues if you have GCMS, NMR colleagues, please feel free to share the surveys with them. We would really appreciate your input. And then finally, as I promised to one of the people who asked a question, we do have a reporting standards paper that has a checklist of things that should be reported in terms of quality control. So you can check out this paper, and Renilan is going to present a poster on this, so poster 1507, so come talk to him directly if you have questions. This QR code takes you to mQACC website as well. If you would like to join the consortium, we are welcoming new members. There is a membership application form there. Come join us and come talk about these important issues and how we can harmonize our practices and move the field forward. So thank you for being an amazing audience, and I hope you enjoyed the rest of the conference. And I'll flash the QR codes if anybody didn't catch them for GCMS and NMR.